Ocean currents are large-scale movements of water within the Earth's oceans that play a crucial role in regulating global climate, distributing heat, nutrients, and influencing marine ecosystems. Here's an overview of the science behind ocean currents in 8 to 10 short paragraphs. Driving forces. Ocean currents are primarily driven by two factors: wind and density differences. Surface currents, which occur in the upper 400 meters, 1,300 feet, of the ocean, are mainly driven by winds blowing over the ocean's surface. These winds create friction and transfer their energy to the water, causing it to move in the direction of the prevailing wind. Coriolis effect. The Coriolis effect, caused by Earth's rotation, deflects moving objects, including air and water, to the right in the northern hemisphere and to the left in the southern hemisphere. This effect influences the direction of ocean currents, causing them to curve clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Ekman transport. Ekman transport is the net movement of water due to wind blowing over the ocean's surface. It causes surface water to move at an angle to the direction of the wind, with deeper layers of water moving in the opposite direction in a spiral pattern known as the Ekman spiral. This process contributes to the formation of surface currents. Density differences. Density-driven currents, also known as thermohaline currents, occur due to differences in water density caused by variations in temperature, thermo, and salinity, haline. Cold, dense water sinks, while warmer, less dense water rises, creating vertical circulation patterns known as thermohaline circulation. These currents are responsible for deep ocean circulation and play a crucial role in redistributing heat and nutrients globally. Types of currents. Ocean currents can be categorized into two main types: surface currents and deep currents. Surface currents, driven by wind and affected by the Coriolis effect, move horizontally and play a significant role in redistributing heat and nutrients across the oceans. Deep currents, driven by density differences, circulate water vertically and connect the surface with deeper ocean layers. Global conveyor belt. The global ocean conveyor belt, also known as the thermohaline circulation, is a key concept in oceanography. It describes the interconnected system of deep and surface currents that circulate water and heat around the world's oceans. This circulation pattern influences climate by transporting warm water from the equator towards the poles and cold water from the poles towards the equator. Impact on climate. Ocean currents play a critical role in regulating Earth's climate by transporting heat from the equator towards the poles and vice versa. For example, the Gulf Stream, a warm ocean current in the North Atlantic Ocean, helps moderate temperatures in Western Europe, making the climate milder than it would be otherwise. Ecological importance. Ocean currents influence marine ecosystems by transporting nutrients, larvae, and plankton across vast distances. Upwelling zones, where deep nutrient-rich water rises to the surface, support productive fisheries by providing nutrients for phytoplankton and other marine organisms at the base of the food chain. Monitoring and research. Scientists study ocean currents using a variety of tools, including satellites, drifters, buoys, and underwater instruments. These technologies help monitor current patterns, understand their dynamics, and predict their impacts on weather, climate, and marine life. Human impacts and conservation. Human activities, such as climate change, pollution, and overfishing, can disrupt ocean currents and their associated ecosystems. Conservation efforts aim to protect marine environments and maintain the health of ocean currents, ensuring their continued role in regulating global climate and supporting biodiversity. In summary, ocean currents are dynamic and complex systems that regulate Earth's climate, distribute heat and nutrients, and influence marine ecosystems globally. Understanding the science behind ocean currents is essential for addressing climate change, conserving marine resources, and sustaining healthy ocean environments for future generations.